Here's a full related rates problem. So a windlass is used to tow a boat to the dock. The rope is attached to the boat at a point 15 feet below the level of the windlass. If the windlass pulls in the rope at a rate of 30 feet per minute, at what rate is the boat approaching the dock when there is 25 feet of rope out? Write a sentence explaining the meaning of your answer. This is very important. Just because you can do the calculus doesn't mean you understand what you did. So the sentence tells me that you understood what it was that you were doing and that what your answer means. Okay, so first things first, we want to figure out what we're given and what we need to find. So we were given, let's see, what rate were we given? We're usually going to be given some kind of a rate. So it says the rope is attached 15 feet below. The windlass pulls in the rope at a rate of 30 feet per minute. So there we go. We see this keyword rate and we're like, yeah, there's talking about a rate. So the rate of change of the rope is 30 feet per minute. Okay. Let's actually, we already had the picture drawn for us, so I kind of skipped over that. Let's go back to the picture. So if you didn't have this picture, let's figure out how we would draw it. So we draw our windlass, and we have a rope that's going down to the boat, and then obviously it makes a right triangle, and then we have to decide what is constant and what is a variable. So what is not changing in this picture? Well, it says that the windlass is attached 15 feet below the level of this is the windlass, okay, and then the level of the water or the boat is 15 feet below. So that is not changing. That is constant. That's why we can write a 15 there. It is constant. But what is changing? Well, the rope is changing, right, because it's pulling this in slowly. And as it pulls it in slowly, it's going to change this triangle, right? And it's going to get the boat closer and closer to shore. So x is also changing. That's why x has a variable, why this length has a variable, why the hypotenuse of our triangle also has a variable, because those two things are changing. So what do we know about this rate? Now I can write what that rate is, right? Because I hadn't really defined that variable before. But since I did in the picture, now I can say the rate of change of z with respect to time is, and it says that it's pulling it in at 30 feet per minute. So is z getting bigger by 30 every minute or smaller by 30 every minute? Well, it's getting smaller, right? So this would be negative 30 because negative means it's getting smaller or having a decrease. So I'm given that rate. Let's see, what else am I given? Well, really nothing else. The rest of it is what we use once we find it. Okay, so then it's asking, what am I finding? It says, at what rate is the boat approaching the dock? So I'm trying to figure out how fast this is changing, right? How close the boat is to the dock. So I'm trying to find dx dt, the rate of change of x with respect to t, when... And that's when you see this word when. I hate keywords because you start to like overthink them. You know, every time you see the word and, you like add or you multiply or whatever they tell you in elementary school. But, you know, it's important to kind of mark up these related rate problems. So we looked for a rate. Now we're going to look for what we were supposed to find. You know, at what rate is the boat? That's what we're looking for. And then it says when there is 25 feet of rope out. So we're trying to find the rate when z equals 25. Okay, now let's go ahead and see how are they related to each other. We still don't have an equation to differentiate because we don't know how z and x are related to each other. Well, they're a right triangle, right? And since it's a right triangle, we know how the sides and the hypotenuse of right triangles are related to each other. We know that x squared plus 15 squared is going to equal z squared. That's the Pythagorean theorem. So now I know how every one of these variables is related to each other. I know what I'm supposed to find. I know what I'm given. And everything that is constant is put in as a number, and everything that is not constant is a variable. Okay, so I think we're ready to differentiate. So let's go ahead and differentiate. So we're going to have 2x squared. Now remember, this is not 2x squared, 2x. Remember that x is a function of t, not a function of x. We're looking at the derivative with respect to t. So x has to be implicitly differentiated as well. So this is the rate of change of x with respect to t, plus 15 squared. What is the derivative of 15 squared? Remember, I'm going to make a stamp. The derivative of a constant is 0. Okay, so it's always just 0. And then I have 2z dz dt. Okay, because all of those are implicit with respect to time. Now, I'm looking for dx dt. So let's fill in what we know. So I can just erase that 0 so it's not there. What do I know? I'm given that dz dt equals negative 30. So wherever there's dz dt, I can replace that with negative 30. Okay? And I'm looking for dx dt when z equals 25. So everywhere there's a z, now that I have differentiated and found the rate, I can go ahead and plug these numbers in. I can't plug the numbers in until I have found that rate, until I have differentiated, because they're still changing. Now we can find how much they're changing at a specific point. So I see that I have a 2 on both sides, so I'm just going to divide both of these by 2 right now. So I have x. You don't have to, it's just a little less math you have to do. My pen is going crazy. I keep having to reset. Okay, x dx dt equals 25 times negative 30. And we're at negative 750 for that. Okay. And now I'm like, well, what else do I do? I can't get dx dt by itself. I still don't know x. Well, we do know how x and z are related, don't we? So this triangle is constantly changing. As this rope is pulling the boat in, x and z are both changing. But at the exact moment that z equals 25, I can find the new triangle and I can find x. So if this equals 25, then I know this triangle is 15 squared plus x squared equals 25 squared. So we have 225 plus x squared equals 625. So x squared equals 400. Therefore, x equals 20. And you're like, but wait, what about the plus or minus? Well, think about it. Can x be negative? No, because x is how far the boat is away from the shore. Like, it can't crash into the cliffs and then go 20 more feet, right? So we don't need to keep the negative 20. This is one of those moments where you have to think of real world questions and decide if your answer makes sense. Okay, so x is 20 when the rope is at 25 feet. So now I can take everywhere that I have an x and I can replace it with 20. So now I can just divide both sides by 20. And my final answer, because I finally have dx dt by itself, because I'm looking at the rate of change of x with respect to t, is going to be negative 37.5. And we have to label this. It's going to be feet per second, because that's a rate of change, and we were talking in feet and seconds. So that means that the x right here is decreasing by 37.5 feet every single second. You might have wanted to leave this as a fraction, and you can. You totally can, because it's precise. But a lot of times in real world problems, if I said, you know, negative 75 over 2, that doesn't tell people a lot. So that's a lot of times when we end up into the decimal, as long as it's a truncated decimal and not a repeating or an irrational, we'll go ahead and do the decimal.